The following lists midterm and final exam grades for a sample of students in English 101. So we have some midterm grades and some final exam grades. All right, the first thing that we want to do, just to see if there happens to be a correlation between these sets of data, is to create a scatter plot. All right, so I'll do this as quickly as I can, but this isn't always the simplest thing to do by hand. To create a scatter plot, it's basically just a mathematical plot like in algebra, but with only an x and a y axis in quadrant 1 usually for statistics. All right, these midterm grades, they range from 50 all the way up to 93. So I think what I'll do is I'll start at 50, and then I'll go up to 100 by tens. But this is a broken scale, so I'm going to indicate that because the first tick mark isn't equal to 50 units. It's broken there. All right, the final exam scores, looks like we go from 70 up to, let's just say 100. So 70, 80, 90, and 100. Okay, and again, that's a broken scale. All right, now I plot my data, so 82, 94. So 82, 94 would be approximately right there. 65, 77 might be about right there. 93, 94. 70, 79. 85, 95. 50, 70. 95, 97, 80, 91. All right, so here's my scatter plot, and as you can see, it looks like there's a pretty decent linear relationship between these variables. We can kind of visualize and mentally picture a line that best fits that data. All right, but a scatter plot's not enough to know that for sure. What we need to first do is come up with a correlation coefficient. So to do that, we will enlist our calculator. So we need to take our data and put that into the list editor. If you already have some data, you can either type over it or you can clear out your list first, whatever you prefer there. But the X data is going to go into L1. That's your independent variable. And instead of having you have to decide what's the independent and what's the dependent, it's just labeled for you for simplicity. So 94, 77, 9, and so forth here. Okay, and always double check your data to make sure you've put it in correctly, because the calculator is going to do everything for you here. So if you mistype your data, it doesn't matter how correct everything else is from that point. The wrong data is going to lead to the wrong answer. So just check your data real quick. All right, so once you've done that, go back to the Stat button here. Scroll past the Calc menu, which does have actually two different linear regression functions inside it. They're there for historical reasons. Just keep going until you get to tests, because we always do a hypothesis test with our linear regression. So get to Tests submenu and then scroll down. Takes you a moment, but you'll get down to linreg t-test. And the only inputs it needs here is your X data and Y data location. You just leave frequency set to 1, and then the alternative hypothesis symbol set to not equals. The regression equation you can leave blank, and then just press calculate, and it will compute everything that you need here. All right, so the correlation coefficient, you scroll down, and it's usually the last thing in the list here. So R equals 0.960. All right, so there you go. 0.960 is our correlation coefficient. Now, there is an R squared. It's literally just the value of R, and it's been squared. Some classes use that as opposed to the value of R. We use R, so just make sure you choose that one. All right, now the equation of the regression line. So the equation of the regression line is a line that's going to be in the form y equals mx plus b. And if you'll notice in your output at the top, it says y equals a plus bx, which is really similar, but just kind of rearrange the terms, and like instead of b you have, or instead of m you have b. But it's a line equation. That's it, the thing that's important here is that the value b is multiplying just the variable x, so it's a line equation. All right, regardless, a and b, those coefficients are provided in the output here. So b is, we'll say 0.65, all right, and that multiplies x. So we can say y equals 0.65x, and then a is 36.81, and that would be our line of regression. Okay, now the line of regression is effectively this line, what we're looking at here in this scatter plot. So y equals 0.65x plus 36.81. So if you actually took the time and care to go through, plot that line perfectly, that's probably what it would look like. All right. Now the thing is, what we're going to do is we're going to use this line for prediction. So it has to be meaningful. So for instance, if that correlation wasn't very high, then we wouldn't be able to use this line to make meaningful predictions. So to ensure that we have meaningful predictions, R needs to be very close to 1 or -1, but close doesn't really tell us exactly how close it has to be. What we need to do is we need to do a hypothesis test. And so the rest of this second part of B is actually asking us to do a hypothesis test. And the hypothesis test looks like a null hypothesis of the form, rho equals 0, and an alternative of rho does not equal 0. And what's going on there is rho is the population correlation coefficient. R down here is the sample correlation coefficient. So this sample correlation coefficient is very high, but is it enough to say that the entire population is correlated? So if the population correlation is non-zero, it's enough to say that it is correlated. If it is 0, then it is not correlated. All right, so to know for certain, we have to do a hypothesis test, which includes calculating a p-value. And it just so happens that this output screen also provides a p-value, which, if you'll notice here, is 1.55 e minus 4. So that's going to be 1.55 times 10 to the negative 4th power, or 0.000155. Now, to do a hypothesis test, we have to take our p-value and we have to compare it to our level of significance. So the p-value as a percentage is 0.0155%. The level of significance they want us to use is 1%. The p-value is much lower here, so we're definitely going to reject the null hypothesis. All right, now if we reject the null hypothesis, we're saying this statement right here is effectively false, which leads this one to be basically true. So the true statement is that the population correlation coefficient is non-zero, meaning that there is a statistically significant correlation. So yes, go back and answer that. And because we know that, we can use this line of regression for meaningful predictions. So if we have some student here who scores a 76, for instance, if we go up and see where that 76 meets that line and try and predict what this y is, all right? Well, it looks maybe about like 87, but it's kind of hard to tell exactly if that's true based off the scale of our drawing here. But luckily enough, we have the line equation, so all we need to do is just take an x value of 76, plug that into the line equation, and we'll get a prediction. So 0.65 times 76 plus 36.81 gives me 86.21. So the student here that got a 76 on the midterm should expect about an 86 on the final exam.